Okay, so we're going to finish up with some construction. And so this is really kind of a practical finish here. Through the day here, we've seen some pretty solid specifications now that are coming from Seattle, San Francisco, Portland. There is a lot of pretty darn good solid guidelines now for bioretention design. We've still got a ways to go, but there's a lot better design guidelines now than we did 10 years ago, much better. Where I think the next frontier is as far as improving practice is in construction. This is new to a lot of contractors, and there's a lot of particular construction techniques required for bioretention that they're probably not familiar with. Same with permeable pavement. We have a long way to go as far as getting the construction community trained up in this stuff. So I would say this is the area we're lagging the farthest behind as far as getting things up to speed and really running smoothly. And one of the problems is it's challenging to get the construction folks to trainings like this. You know, they're not getting equipment operators. They're not getting paid unless they're on their equipment. And developers, they're somewhere else, and construction management and all that. They're just different folks. They have different peer group, and oftentimes they're not getting paid. You know, whereas we, you know, I think most of us are getting paid for this day. They're not. So it's been challenged getting construction folks into trainings, and somehow we need to do better at that. The best turnout I've heard so far for construction training was they paid the folks to come. What does that mean? That means we should expect to spend, as designers, spend more time on the job working with your construction folks. The last facility I built, I was every single morning talking to them. We're building a permeable parking lot. We're building an infiltration facility, right? Because what have they been told all their lives for a pavement subgrade? What do you do to it? Pound it to rock. Now we're telling them, no. We want it fluffy and we want it to infiltrate. And they're like, what? So it's the same with bioretention. A lot of new stuff. Expect to have to spend some more time out there with the construction folks, making sure everybody's on the same page, all the way from pre-construction to the field and finishing up. That's just, you know, that's to be expected. I mean, it's new stuff. And if we're not getting the construction folks into trainings, it's kind of the training's happening in the field, right? And that's us out there working with them. Really important there is pre-construction meetings, getting everybody on the same page. Really important in that pre-construction meeting is to point out any performance bonding. Subgrade doesn't infiltrate because you drove equipment in there, there's a consequence to that. You deliver media that doesn't meet the specification, goes back, there's a consequence to that. You know, make sure everybody's clear on all that stuff. So, at any rate, I think our our training is right now. Our training is happening in the field. So that's the way it goes as we're building. The construction phase is where we have more potential to mess up receiving waters than any other phase of the project, by far and away. Interesting research back, 95. Corish, this is from Midwest. Stream biota significantly reduced at sediment solids, suspended sediment in this case, levels of 50 to 80 milligrams per liter. That's pretty low. Tom Schuler from then Center for Watershed Protection, reporting a median TSS concentrations of over 4,000 milligrams per liter, leaving construction sites with no temporary erosion sediment control. Well, that's not happening anymore. You can't, well, maybe I guess you could get away with that, but you're probably going to get red flagged and shut down pretty darn quick. So that's probably not, we probably don't see that much. But up to, you found 280 milligrams per liter with temporary erosion sediment control. This is a phase where we really have to be careful for inputs to receiving waters, but also to degrading the facilities. And that's a pretty nasty picture right there, huh? That job would get shut down quick. Some considerations for improved construction. Really sort of the big issues here are improved site design, construction planning and sequencing, operator training, and proper equipment. So those are kind of the big categories to think about when we're building this stuff. Really important here is that construction planning and pre-construction meetings. Minimizing site disturbance. Well, protecting trees. Over-compaction, your subgrade, this is your biggest concern. Sediment's a big concern. Compaction is a much bigger concern. You can see compaction down fairly deep, reaching 2 and 3 feet, measurable compaction if that subgrade is wet and you're driving heavy vehicles on that. If you have that happen, that's going to be a very difficult scenario to fix. It's going to be an expensive scenario to fix. So compaction is critical. And then effective erosion sediment control. So what do you, this picture is from High Point, again, West Seattle. What do you see going on here that looks kind of interesting? And this is a very good site. So this would be a picture of a very good construction site. What do you see going on there? So underneath those bags, I'll tell you what that is. That's filter fabric. What do you think's underneath that filter fabric? Pervious concrete sidewalk. Amazing. They followed the guidelines. Ran the filter fabric long, wrapped it over the top of the pervious concrete, secured it while construction's going on around it. So they protected that. The upslope stuff is all stabilized before they go in and complete the bioretention area. So they've got this place wrapped up, stabilized before they're finishing up the bioretention area. Nicely done. So out in the street there, you see some orange bags. What's going on there? Blocking the entrance to the bioretention area. So this is not always the case, but here they were fortunate. There was a parallel storm system. They could use that gutter. Those gutters went to other facilities. So in this case, the water could bypass this system while they're building and while they complete and establish it. Block those, the curb inlets, they blocked them so that water goes around during the construction and establishment. City of Seattle found that the sandbags are not the best thing to use because they break and you get sand everywhere, you know, they fall apart. They actually used, after a while they started using just pack some asphalt in the curb inlet and then they could knock it out when they were done. Important message here is that great site, well done, got everything buttoned up and proceeding in order. Construction considerations, a big one, minimizing site disturbance, and this has a lot to do with site planning. Up on the larger right-hand picture, you see some arrows, the building that's being constructed, impervious parking, the permeable driveway to that building, and then a construction access. So this is actually a project of Chris's. So in this case, they've got a separate construction access to the building while they're building other stuff, the permeable pavement and other bioretention. This is a great example of good construction planning. This is how you're thinking ahead. How do I minimize disturbance? How do I minimize disturbance to my facilities as they're being built? Another great example here is the smaller picture on the lower left. This is Kevin here up in Port Townsend, and he's proudly showing the difference between his project on the right, adjacent project to the left. And his project to the right was following a kind of a low impact development approach, and they were minimizing their site disturbance all over the site by, after they've got their grading done, they got the road in, then they stabilized all of the different lots and are only working on one lot at a time. In this case, it's kind of a special case because they had a local junior college construction class were the people building the homes. So one home per year, right? One home per class. And all the rest of the lots were stabilized right after construction, and he virtually had no sediment coming off of his site to the right. And what he's showing us is that his neighbor to the left there has opened up the whole site. There's raw dirt everywhere, and sediment is just pouring off of that site, and that's what he's picking up and pouring off there. It was a great demonstration of the two approaches and how kind of a low impact development approach as opposed to kind of mass grading and opening the whole site up, and the difference that can make. Construction planning is critical. The overall site design, we've talked about this, reducing the development envelope, that makes a huge difference as far as what's disturbed. I want to just say a little bit about training, move into some more detail on construction. So this is something you want to identify right away. If, in fact, there are special requirements, you've got a contractor how many here have to deal with low bids? You can write into your bid specs certain criteria, particularly for permeable pavement, different subject, but for permeable pavement, for example, you can write in certain levels of certification those contractors have to meet. You can also write in that that contractor has to have demonstrated a certain level of installation expertise into those bid specs. And if they are not meeting that criteria, then you need to identify any training that might be needed up front. That's part of this, pre-construction and understanding what are the needs and who's going to be installing this stuff. So identify training needs, write into your bid specs if possible, a certain level of expertise required, minimum expertise for the job, and also identify if you need some training for some of your construction folks up front. Native soil variability, and we saw pictures of this. Chris showed you some pictures from Seattle, that soil is variable. Count on it. Now, instead of building one centralized facility, we're building facilities dispersed around the site. The opportunity to run into different soil can go up. So, how do you deal with that? If your cells look like your test pit and your design, you're good to go with your design rates, good for you. You were lucky. If you start installation and you see that there are there's other soil types, particularly lower permeability, this is something you need to plan for. So you should be thinking about this at the design phase, not the day you discover that you've got till and you thought you had outwash. And there are ways to deal with that. Again, if you're lucky, you have the room, you might be able to increase the size of the bioretention areas to deal with that lower permeability. You might be able to over-excavate and add more storage to that area. You might be able to increase ponding depth if your drawdown can be maintained. And you might be able to add an underdrain if you've planned for it. So those are examples of things that you should be thinking about early on if we run into different soils. And how do we deal with that? And it's going to depend on the site. But the important critical message here is think about it ahead of time. Overcompaction. As I mentioned, this is probably your biggest concern. There are ways to deal with sediment that are pretty straightforward. Compaction can be more difficult. Preventing overcompaction, again, critical. No excavation, soil placement, or soil amendment during wet or saturated conditions. That's really written in. You see that in both the LID manual and the Stormwater Management Manual. That's very important. Of course, subgrade compaction, but also your media can be dramatically affected if it's too wet. You want to be operating your equipment adjacent to the facility, not in it. Really, this should not be a problem unless you're building a big facility. And hopefully that's not going to be the case. Most of the facilities, it's quite easy to reach everywhere in that facility with the current machinery, all the way from a mini excavator to, if you need much larger machine. And so you see this last bullet, if the machinery must operate in the facility. That should just be really a rare case. I would update this bullet to say, if that's really the case, that's what's happening, I would put down some sort of protective sheeting, steel plates, even wood, and or excavate in stages where the excavator is never operating on the actual finished subgrade, but operating on partial excavation and pulling back above what your final subgrade is going to be. So there are other techniques to deal with that, and it should be kind of really a rare occurrence. Steel plates, that's been used all the time, and we do that all the time in permeable pavement. And if you have a big bioretention area, that's another possibility. Understand that your vehicle loading prism, you're going to have some compaction. One way to deal with this, and Seattle has done this successfully for years, is to modify your media to deal with that needed compaction. So if you have a roadway, flush curb, and then, 2 or 3 feet of shoulder that you want to be able to grow plants, and it's sort of part of the landscape and part of a bioretention installation. There are media guidelines for developing media that's more granular and that will maintain permeability when you compact it more. All right, so we have guidelines, we have design experience and construction experience with that. So that's one way to deal with that additional compaction that might be needed in the vehicle loading prism. This is something that's relatively common. I don't know if it's because operators think it's pretty, it looks nice and clean, but you'll see excavation of bioretention areas with smooth buckets. And there are soil types that if using that smooth bucket will, especially if it's wet, will smear that surface and reduce that permeability at that surface. So That's something that's very easy to watch for. Again, this is where you might need to be out on the job, right, and watching installation, but you want that subgrade scarified. Also, another benefit can be tilling in some compost at that interface. Good construction technique there. Get rid of the smooth face buckets and till the subgrade.